My whole life, I have been terrible at video games. I'm talking absolute bottom of the barrel, first dead and smash at the sleepover type of bad at video games. And so I became a good software engineer way before I ever learned how to learn to play a video game. And when my college friend, world famous Valorant coach Woohoojin, started to try and teach me the game, we kept running into this problem where, for me, my brain was hardwired for engineering, which is very at odds with how you get good at how to play video games. I suspect that I'm in the minority here, and because of that, I'm going to flip the script for this video. And I'm going to say, this is why I believe that learning to get good at video games can actually be detrimental for how you think about learning to program. More specifically, I'm going to drill down on why I think that it's important to learn programming / software engineering in a different way than you learn most other skills, like how to click heads or whatever your game of choice is. So how do people generally learn to play video games? Here is the one leap of faith that I need to make for this entire YouTube video, okay? You're here watching a video on YouTube that's adjacently related to video games. So I need to kind of assume that that means that you've very likely watched people play the games that you enjoy. And more often than not, when people watch people play games, the people that they're watching are better than them at the game. That's it. That's the leap of faith. As you watch other people play video games, you learn how they approach the same problems that you run into. Every day, there are thousands of hours of new footage from professional players at these games uploaded to the internet that you can watch and learn from. If your favorite game is Rocket League, I'm sure that one of these two clips looks more natural to you. If your favorite game is Valorant, I'm sure that one of these two clips looks more natural to you. If your favorite game is Minesweeper, dude, I don't even know how that game is played. I still don't know. I mean, I kind of know. I know a little bit about how that game is played. When you start trying to play the game yourself, it is often incredibly correct for you to just try to emulate better players. Even if you don't fully understand why they do the things that they do, more often than not, it is better than you just flailing around and doing whatever you think is best. Now, this might be slightly up for debate. Like, I know that some people don't agree with this sentiment that you can just copy better players, but if you don't agree with that sentiment, you're gonna like where the rest of this video goes. I know that you know that a but is coming, okay? But why shouldn't we do this when it comes to engineering? First, we have to establish how you might be learning to program. If you're past your hello world era and closer to your I need to find a job era, you're probably looking at big companies and asking yourself, how do they solve problems? This is the functional equivalent of watching professionals play your favorite games. I mean, how do people that are better than me at engineering solve these problems? There's a really practical reason for you doing that, and that's that at some point you might want to be employed by one of these companies. So I'm not out here to be like, don't learn React if 90% of the jobs that you're interested in applying for ask you to know React. But eventually you're no longer looking to solve problems because it helps you build a resume. You're looking to solve problems because it's what a company is paying you to do. This is where we need to diverge from the video game playbook. The fact of the matter is that 95% of the engineering problems that you're solving, you shouldn't just do what bigger companies are doing because you're operating under very different constraints than those bigger companies. Now, obviously, there's an asterisk here, okay? If you're literally working at Google or Meta, ignore this. But video games are a very different model. They put everyone into this convenient box. Everyone has the same exact set of constraints on them. And so the best players are just making better decisions within these exact same constraints that you are under. As a result, it's much more likely that you can take these strategies one-to-one into your games. There's nuance behind this, but you'll get farther than you expect just ignoring that nuance entirely. With engineering, you can never ignore that nuance because you are almost certainly not operating under the same exact set of constraints as Meta or Google or whatever other massive company that you're looking at how they solve the problems. You probably have fewer engineers, fewer users, and you do not have the same monetary runway to solve problems the way that these massive companies do. When you look at things like frameworks or even just blog posts that are posted by these companies, you have to keep in mind they are first and foremost solving their own problems. The idea that you might benefit from the work that they're doing is an absolute afterthought. As a result, there's no guarantee that your problem is complex enough to warrant all of the trade-offs from adopting something like React or Angular or Meta's new hotness Style X for your CSS, right? Any of these things, your company might not be structured in a way that will actually benefit from it. Your problem might not be structured in a way that will benefit from it. There is no guarantee that copying the design of Instagram is correct for your company's scale. For every engineering decision that can handle complexity in scale, there is a trade-off around velocity and maintainability. You will move slower. It will be harder to maintain that code. That is the trade-offs that massive companies have to make. You might not be in that position. You might not have to make that trade-off. So don't make it. It's important to ask ourselves if the trade-off is worth it to us just because it's worth it to Google. Look, I can't provide to you a framework that's going to help you make these decisions on whether or not the trade-off is worth it for you. Like, engineering isn't that flowchartable. What I can do is help you to shift your mindset around doing things the way that big tech companies do. I believe that the overarching issue here is that as engineers, we're taught that we need to think about the future. That's the entire idea behind designing for scalability and extensibility. The problem is that you shouldn't necessarily ask yourself, what if I get to Facebook level scale? What if I end up with Google's complexity? And I really want to nail this in. So I'm going to show you an image here that I feel like perfectly contradicts this methodology. This is Google's first server, and you might notice that there's some Lego involved here. It's one server with Lego. This was their plan for scalability. They knew that the server might have to grow, so they made it a custom housing out of Lego bricks. Lego was their scalability plan. It's important for you to plan for how you want to extend your project, okay? I'm not trying to say that you should just only immediately solve what's on your plate today and never think about the future. But Google thought about the future and they came up with Lego bricks. So you might not need a solution that's acceptable by 2024 Google standards. You might just be looking for the 1996 Google standards, or maybe we'll give you 2000 to the point where they probably got rid of all the Lego.